Alright, so in this lesson we're going to explore polygons and their angle properties. So a polygon is basically a shape. We have different types of polygons. We have a triangle which has three sides, and the sum of the interior angles of a triangle measures 180 degrees. Okay. We have a quadrilateral which has four sides. So a quadrilateral, could be a rectangle, or it could be any four-sided shape. Well, how many triangles could we draw in a quadrilateral? Just two. Any way you slice it, you'll end up with two triangles. So the number of triangles that can be drawn inside a quadrilateral is 2, and the interior angles inside a quadrilateral, because we have two triangles, they add up to twice this number, which ends up being 360 degrees. Now what about a pentagon? A pentagon has 5 sides. The number of triangles that can be drawn inside a pentagon is 3, meaning that the sum of the interior angles of a pentagon is going to be 3 times 180, 540 degrees. Okay, a hexagon has 6 sides, 7 sides, 8 sides, so let's fill in the rest of this chart. So, as you can see, as the number of sides of the polygon increases by 1, the number of triangles that we can draw inside a polygon increases by 1, and the sum of the measure of the interior angles increases by 180. So, make a conjecture about the relationship between the sum of the interior angles of a polygon S, we'll call this S, and the number of sides of a polygon N. So again, what's a conjecture? Kind of like a general prediction. Okay? So based on this chart here, I think it's safe to say that the number of triangles in a polygon is 2 less than the number of sides. Or, if we were to write a formula, the sum of the angles in a polygon S equals 180 degrees times the number of sides take away 2. So now instead of filling out the chart for each shape, let's put our conjecture to use. So use our conjecture to predict the sum of the measure of the interior angles of a dodecagon which has 12 sides. Verify your prediction using triangles. Okay, so if we use the formula, the sum of the interior angles is 180 n minus 2, where n is the number of sides, so the number of sides is actually going to be 12. Sorry, I don't know why I put equals there. 1 second. 12 minus 2, so it's going to be 180 times 10, which is going to be 1800 degrees. Now let's try and do it by drawing triangles, so inside the shape. So this is a dodecagon. It's got 1, 2, I'm trying to draw 2, just not, there we go, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we start drawing triangles inside this dodecagon, there's 1, there's 2 triangles, Alright, we end up with, count them, pause and count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. And we know that one triangle adds up, all the angles in a triangle add up to 180. So 10 triangles that we're able to draw times 180 gives us 1800 degrees. So we come to the same conclusion. Alright, let's move on to part 2. Notice here that we have a rectangle, and notice that these little squares here, they indicate that inside the rectangle we have four 90 degree angles. Now inside any shape we have an interior angle right there, and on the other side is what's called the exterior angle. So here in this shape we know that this line right here is a straight line, so it's 180 degrees. If this is 90, that means this is 90, so we have four angles, exterior angles that are 90 degrees, so the sum of all of the angles that are exterior to this shape is 360 degrees. Okay, our next job is to figure out what are the sum of the exterior angles in this shape right here. Okay, so as we can see, I've given you the interior angles. Our job is to figure out the exterior angles. So our first exterior angle that we're going to find out is x. This whole angle right here, this whole line is 180 degrees. So x equals 180 minus 83, which is 97 degrees. What about this angle right here, y? Again, this whole angle is 180. This part right there is 63. So y equals 180 minus 63, which equals 117 degrees. What about w? Well, again, 180, because this whole angle right here is 180. This part is 67. So this part right here is going to be 113. And the last one, this one is 147. This whole angle in here is 180. So 180 minus 147, z equals 33 degrees. Now to find the sum of the exterior angles, we're going to add up all the exterior angles together. So we're going to add up this angle, this angle, this angle, and this angle, or not that one, this one, together. So we're going to get that the exterior angle is 33 plus 113 plus 97 plus 117, which gives us a total of 360 degrees. So we had that up here for this shape, the exterior angles gave us 360 degrees, and down here for this very different looking shape, the exterior angles also, the sum of the exterior angles also gave us 360 degrees. So what do you think that we could deduce from this? Well, we can deduce that the sum of the measures of the exterior angles of any polygon is 360 degrees. Let's look at an example in here. Measure the exterior angles of the pentagon to determine the sum of the exterior angles of the pentagon. Well, can't really measure it on the computer screen, so I'm just going to tell you what the angles are. The exterior angles, that is. Sorry, I'm going to give you the interior angles, and then you're going to discover what the exterior angles are, find the sum, and see if it gives you 360 degrees, like we predicted. So there we go, those are the interior angles of this pentagon, except for the fact, sorry I messed up, this angle right here, because they all have to add up to 540, should be 110. Alright, so there we go, that's 110. So there we go, these are the interior angles. So now let's find out what the exterior angles are. Remember that a whole line, supplementary, is 180 degrees. So that means that W is going to be 80 degrees. Over here, since this is 115 and this whole line is 180, that means X is going to be 65. Over here, Y is 67. Just going 180 minus 113. Here Z is 70. And V is 78. So now let's find the sum of the exterior angles. So the sum equals 78 plus 80 plus 65 plus 70, the sum of the exterior angles, which if you calculate that out is equal to 360 degrees. Alright, let's look at this example. Determine the measure of each interior angle of a regular pentadecagon. Okay, so a pentadecagon is a 15-sided polygon. So we're just going to use our formula. S equals 180 n minus 2. So which n is the number of sides, which is 15. So we have 180 15 minus 2, which equals 180 times 13, which equals 2,340 degrees. But remember that this number that we found right here is the sum of all the interior angles of the pentadecagon. We want to find out how much one interior angle is. Just one interior angle. So how many interior angles do we have? Well, since we have 15 sides, we have 15 angles. So we have to take this number divided by 15, gives us 156 degrees. So the measure of each interior angle in here is 156. Okay, so let's look at this question here. A floor tiler designs custom floors using tiles in the shape of regular polygons. Can a tiling pattern be created using regular hexagons and equilateral triangles that have the same length? Explain. Okay, so regular polygon means that all the sides are equal. Okay, so we're talking about a regular hexagon. So let's draw a regular hexagon. So there's a regular hexagon. These lines that I've drawn through it, each side indicates that all the sides are equal. So let's find out what each interior angle of the hexagon is. Okay, so to do that, first we need to find out what the sum of all the interior angles of a hexagon is. So we know that the sum of the interior angles is 180 times n minus 2, where n is the number of sides. So equals 180, and the number of sides is 6 minus 2. So the sum of all the interior angles of a regular hexagon is 720 degrees. Now how much is one angle? Well, it's got 6 sides, so divide by 6, and we get that each angle is 120 degrees. Is each angle. Now, what about in an equilateral triangle? Remember that an equilateral triangle is a triangle where all the sides and angles are equal. So that means that each angle in here is 60 degrees. So when we put two regular hexagons together, like that, excuse me for the drawing, two regular same sized hexagons, that's what it's supposed to be, we're left with a triangle in here and a triangle in here, and we know that each interior angle of the regular hexagon is 120, and we know that in an equilateral triangle this angle is 60. So the total, 120 plus 60, is 180. And right here, this is 60, 120, 60, 120, which gives 360 degrees. So yes, we can tile using regular hexagons and equilateral triangles. So what do you need to know? As a summary, the sum of the measures of interior angles of a polygon with n sides can be expressed as, so remember, S equals 180 n minus 2. the measure of each interior angle is, once we find the sum, we got to divide by the number of sides. So it's S equals 180 n minus 2 divided by n. And the sum of the measures of exterior angles of any convex polygon is 360 degrees.